Hello, Assalamu alaikum. My dear student, today I am going to discuss about Igcse GCSE Physics Unit 6 Chapter 20 Magnetism and Electromagnetism. Chapter 20, this is the part 2 video. Part 1 video links are given here. Topics: magnetic poles, magnetic field lines, investigate the magnetic field pattern of a bar magnet. First, what is magnetic poles? Magnetic poles. Magnetic poles. What is magnetic poles? Magnetic poles is the region of the magnet where magnetic force is maximum. So magnetic poles are the parts of the magnet that exert the greatest force is known as magnetic poles. Every magnet has two poles, north facing pole and south facing pole. So magnetic poles is the region or space or area of the magnet where magnetic force is maximum. So magnetic poles are the parts of the magnet that exert the greatest force is called magnetic poles. So magnetic poles are the parts of the magnet, parts of the magnet that exert the greatest force, that exert the greatest force. So magnetic poles occur in pairs usually. Magnetic poles occur in pairs. Usually called north pole, north and south pole, north capital N and south S pole. So magnetic poles are the parts of the magnet that exert the greatest force is called magnetic pole. Magnetic poles occur in pairs usually called north and south pole. So iron fillings are attracted mostly to the poles of the magnet. Iron fillings, if there are iron fillings, so iron fillings are attracted mostly to the poles of the magnet, mostly to the poles of the magnet, remember. So magnetic poles are the region, this one is the iron fillings. Magnetic poles are the region where the magnetic force is maximum. So magnetic poles are the parts of the magnet that exert the greatest force. Magnetic poles occurs in pairs usually called north and south. Now, why poles are called north and south? If a magnet is suspended so that it can rotate freely horizontally, will eventually settle down with one pole facing north and other pole facing south. If we suspended it freely, freely. So a magnet suspended so that it can rotate freely horizontally will eventually settle down with one pole facing north and other poles south. This pole is therefore called north shaking pole or north pole, and other one is the south facing pole or south pole. The magnet has been oriented by the earth magnetic field because our earth we have as a large bar magnet. So compass is the application of this effect. Compass is the application of this effect. Remember, compass is the application of this effect. Now, magnetic field. What is magnetic field? Magnetic field. Magnetic field is the space or region around a magnet or current carrying wire up to which the force of influence of the magnet exists is called magnetic field. The space or region, the space or region around a magnet or current carrying wire up to which force of influence of the magnet exists is called magnetic field. So magnetic field is the region or space, spherical region or space around a magnet or current carrying wire up to which the force of influence of the magnet exists is called magnetic field. So if we place a magnet here, then there is a space or region up to which it attracts or repel other magnetic material or magnetic poles is known as magnetic field. So this one is the magnetic field. Magnetic field, remember. So magnetic field is the volume of space where magnetic force is exerted. Volume of space where magnetic force is exerted. All magnets are surrounded by magnetic fields. The shape of the magnetic field can be shown by iron fillings or plotting compass. Plotting compass. Now, magnetic field lines. Magnetic field lines. What is magnetic field lines? The imaginary line which shows or which represent the direction of the magnetic field pattern around. Investigate the magnetic field pattern of a bar magnet. There are two methods, using iron fillings method, using a plotting compass method. First, using iron fillings method. Iron fillings method only give the magnetic field pattern around the bar magnet, but using plotting compass method gives the pattern and direction of the magnetic field around the bar magnet. First, using iron fillings method. Place a piece of paper on the top of the magnet. Say this one is a magnet. Say this one is a magnet here. I have a magnet here, and place a piece of paper. Place a piece of paper like this. Piece of paper on the top of the magnet. Gently sprinkle iron fillings on the top of the paper. Now carefully tap the paper, allow the iron filling settle down on the field lines. Then these iron fillings shows the magnetic field pattern around the bar magnet. Clear? So there are 3 steps here. First, place a bar magnet and then place a piece of paper on the top of the magnet. Gently sprinkle iron fillings on the top of the paper. Now carefully tap the paper to allow the iron fillings to settle down the field lines. Then second method, using plotting compass method. Place a magnet on the top of a piece of paper. So place a bar magnet on the top of the piece of the paper. Draw a dot at the one end of the magnet near its corner. Place a plotting compass next to the dot so that one end of the needle of the compass points towards the dot. Use a pencil, draw a new dot and other side of the compass needle. Now move the compass so that it points towards the new dot and repeat the above process. So now keep repeating until you have a chain of dots going from one end of the magnet to the other end. Then remove the compass and link the dots using a smooth curve. Then you get the magnetic field line. The direction of the magnetic field line is the same as the direction of the plotting compass. You can now repeat the whole process several times to create the overall other magnetic field. So using plotting compass, we get pattern and magnetic field direction.